Hello everyone, it's Mr. Anderson. Today we're going to talk about section 4.2.3 from our CPM Common Core Algebra textbook, and our goal today is to investigate a method beyond substituting and beyond graphing, and we're going to talk about a method called the Elimination Method and when we can use it and why it might be helpful for us to be using. Again, this is our CPM Common Core Algebra book. We are in section 4.2.3, and the first problem we're going to tackle is problem number 55 here. And I've got this one set up in our notes here, and in order to tackle this problem, we are going to follow the method that the book does kind of suggest that we should follow. So check this out. Jeanette is trying to find the intersection point of these two equations. Remember, intersection point is, for our purposes, the solution. Okay? She's decided to use substitution to find that point of intersection. Her plan is to solve that first equation for y, so she's going to go ahead and do that, and then substitute the result into the second equation. We're prompted to use her strategy. Now, I'll admit, using this strategy, and I'm going to walk everyone through this, I'm just copying that first equation down. Using this strategy in this case, it is not going to be the nicest strategy, because we are going to have two fractions that we will have to maintain if we do want that exact solution. So check this out. Solve it for y, which means we get rid of the 2x from this side and bring it over to this side using subtraction. You cancel here. I've got 3y equals negative 2x minus 2, and now we're just going to divide everything by 3. And I will try my darndest to make sure, as these 3's cancel here, that I maintain those fractions here. So I've got negative 2/3 x minus 2/3. Okay, so there's that first equation solved for y. At this point, because we have y already solved and y by itself, now it's a great idea to use substitution. But we're going to sub into, let me use a different color, we're going to sub into the second equation. So I'll take this right here and I'll sub in for y in that second equation. And this isn't too bad, because at this point the denominators of those fractions will get eliminated. And you'll see what I'm talking about here as I multiply by 3, but give me just a moment to write this. Okay, so I've left the blank in there where the y goes, and now I'm going to put in the known value of y, negative 2/3 x minus 2/3, right? So the only thing I've done is I've subbed what I know y is equal to in for y. Now, distributing gives me that, right? I can distribute negative 3 times negative 2/3 x, that becomes positive 2x, and the negative 3 times negative 2/3 just becomes positive 2. Then I have plus 5x equals 16. Okay, I go ahead and I combine my like terms. I get 7x plus 2 equals 16. All right, then I go ahead and subtract 2 from both sides. 7x equals 14. Divide everything by, whoops, I'm not going to show that. Give me a little extra space. I'm dividing everything by 7. 14 divided by 7 is 2. I get x equals 2. Yay, we made it. Okay, now check this out. If I get what's it called, x equals 2, I still have to figure out what y is, so I'll plug back in to this right here using substitution one more time, and then I'll go ahead and I will find out what y is. And this is where maybe the math gets a little bit little tricky. I don't want to say a little tricky. We gotta be very disciplined here, right? So y equals negative 2/3 x. Now I'm going to put something in for x, minus 2/3. Okay, what am I going to put in for x? I'm going to put in what I know x is. I'm going to put in 2. Negative 2/3 times 2 is negative 4/3, and then minus 2/3. All right, and then I go ahead and actually do this subtraction, and I get y equals negative 6/3. And of course, if you simplify negative 6/3, that's just negative 2. So there's my solution for y. So I got the system solved. I got x is 2, y is negative 2. There we go. And I invite you to look at that work. Oh my gosh, right? There's a lot of work there. Okay? Is there another method that could be a better method? Maybe, right? We've talked about graphing. In fact, I set this up ahead of time, and I'm going to invite you to join me over here on my Desmos screen on my web browser. I went ahead and I typed in the two original equations that they gave me. The first equation is the red line, the second equation is the purple line, and I want you to notice what I found. I found that point of intersection exactly where our algebra shows it should be, at 2, -2. Okay? So in this point, even graphing maybe would have been a better option. But the other thing that we're going to investigate today is this thing called the elimination method. And I'm going to show you another example where substitution maybe isn't the best option outright because of the amount and nature of the work that we see here. There's a lot of work, but there's also a lot of opportunities to make some mistakes. So we'll see if we can bypass some of that with the elimination method, okay? But rest assured, if done correctly, all of these things are going to work out and you will get the correct answer, okay? Obviously then, one more time, now I did solve this algebraically, I did confirm graphically, but if I wasn't sure, I could, of course, then plug back in and investigate, hey, do my equations balance? Can I plug in 2 for x and -2 for y? And do I get a balanced equation in both of my original equations? And I promise here I would. Okay, let's jump down to number 57 here. Number 57 is a great problem because it's going to set itself up perfectly for this elimination method that I do want to use for this, but it's also going to have us revisiting how to write some equations from a situation. So this is a great question, and I've gone into the question ahead of time and I've put in some hints. All right, Pat was fishing in a competition at Lake Pisces. He caught some bass and some trout. Each bass weighed 3 pounds and each trout weighed 1 pound. Pat caught a total of 30 pounds of fish. He got 5 points in the competition for each bass, but since trout are endangered in Lake Pisces, he lost a point for each trout. He scored a total of 42 points. All right, I went ahead and I identified the variables that we're going to be after. It says write a system of equations and using the information in this problem. And I'm going to go ahead and write my let statements because ultimately we are going to be solving for the number of, and I'm looking down here, we are going to be solving to figure out the number of bass and trout. This is part C of the question that Pat caught. So that's going to involve my setup here and using these let statements. I'll keep that in mind. I'm going to just let x equal the number of bass Pat caught, and let y equal, I'll put a comma here, let y equal the number of trout that Pat caught. Okay, and that first equation is going to be relative to the pounds of fish that he caught. And I know that the number of pounds of fish he caught are going to be made up of x and y here. I know that each bass weighs 3 pounds, so 3 times the number of bass he caught, and each trout weighs 1 pound. Now, multiplying by 1 doesn't really have an impact on us, but it's maybe a good spot to keep in mind, or a good spot to throw that in there to keep that in mind. And then his total, right, totals stand by themselves on one side of the equal sign. His total is going to be 30 pounds, okay? The next equation is going to be based on his points, okay? And I see it starting right here. He got 5 points in the competition for each bass, and he got he lost a point, for each trout. So again, we're going to be dealing in x and y because we've got some stuff in coming at us in standard form. I got 2 rates, 5 and 1. Okay, 5 points for each bass, but because trout are endangered, he lost a point. Okay, and now, ladies and gents, check out his point total, again, standing all by itself on the one side of the equal sign, 42 points. Okay? We've got 2 well-written equations, and they together, 2 equations, 2 variables, they together are solvable for the sake of identifying what x and y are, the number of bass and the number of trout. Okay? But let's check out part B. Part B says, is this a good candidate for the system? Is this system a good candidate for the elimination method? And it says why or why not. And I'm going to write down, yes, of course, this is a great candidate. And you might say to yourself, well, why? And the obvious answer to that is because, well, a couple reasons, I guess. I would say we've got a situation here where we do not have one of the equations solved for a variable, right? I don't have in either equation 1 or equation 2, I do not have the variable x or y already all by themselves. The other thing, right? I'm going to just make a note. Don't have isolated variable. The other thing that makes this an extremely good candidate, and you can see this right here, I'm going to highlight it, is we have opposites, okay? And that's the crux of the elimination method. Okay, you guys know that opposites cancel each other out, and that's what the elimination method focuses on. We want things that are going to eliminate themselves. I'm going to show you how this works. We're going to check graphically, and we're going to make sure we've got the right solution here. It says solve it and check how many bass and trout Pat caught. Okay, the first equation was 5x plus 1y equals 30, and the second equation, I'm just copying from my work above, was 5x minus 1y equals 42. Now here's how the elimination method is going to work for us. And I'm going to do this part in a different color. All right, we're going to treat this thing like a giant column sum. All right, and just like I've always done, I've stacked my like terms for the purposes of adding them up. I can cancel items out. Okay, now watch what happens here. I can take 5, you know what, did I make a mistake here? I did. I'm sorry. This right here was not a 5x. This was a 3. My bad. Okay, but it doesn't impact my approach. I'm going to treat this thing just like a column sum. I'm going to add up 5x and 8x. I'm going to write that sum right down here. All right. Here's why the elimination method works really, really well. Because what do 1y and negative 1y make? It makes 0y. Now I can write that right here, but you guys all know we don't need to. And then of course I can add those constants, 30 and 42, they make 72. Now look at what happens here. I've got a very solvable equation. 8x equals 72. Here we go. Let's divide both sides by 8, and I get x equals 9. That means the number of bass Pat caught is 9. And I can use either one of these scenarios. I'll use the top one. And I can solve for y. Right? Check it out. I just rewrote that without the x in there. 3 times 9 is 27 plus 1y, and that's equal to 30. And then I go ahead and subtract 27 from both sides, and I get 1y equals 3, which of course tells me y is 3. Okay? Now, it does say to check by plugging these into the original equations. And I promise if you take x and y and you plug them into both of the original equations, it is going to check. It will work 100%. However, another check option we have is Desmos. And I'm going to go ahead here. I'm going to clear my Desmos off, and I'm going to type this in 3x plus 1y equals 30. I'm typing in exactly like I wrote it. And then I've got 5x minus 1y equals 42. Now, the thing I'm looking for, and I've got to adjust my screen, is that point of intersection. And there it is, folks. I can click, and Desmos brings it right up, and there it is. X is 9, y is 3, and you can even write your answer like that. Okay, but we do want to see your work, so you should be showing us that as well. Okay, and then, like I said, you do want to communicate this very easily. Pat caught 9 bass and 3 trout in the fishing competition, period. If you're doing stuff like that, you're making it very, very obvious to your reader exactly what the solution to your system is, okay? So there we go. There's that elimination method, and the key is we've got certain situations that lend itself very, very well to elimination. Last thing I'm going to mention here is there is a little bit of review preview. One more time, just a couple problems. All right, 60 to 62 here. These are going to give you an opportunity to be trying some of these things and an opportunity to come up with some questions. All right, Questions are only good, though, if we seek answers to them, okay? Ladies and gentlemen, thank you for watching, and have a great day.